Okay, welcome to the mathematics revision. This is the paper that was written in 2019 October, November exams, and this was actually question 13 on circle theorem. Alright, so they are saying in the diagram below, A, B, C, and D are points on the circumference of the circle center, or DAT is equal to 40 degrees, BDC is equal to 30 degrees, and AT is a tangent to the circle at A. So what we are being taught here is this, that we have a diagram below where we have A, B, C, D, which are points on the circumference, guys. Alright, then they are telling us that with the center O. So this is the center O. So this is the center. Though the drawing was not all that uniform, so this is the center O. Then they are telling us that like angle DAT. So we have DAT. So we must have a T here which was not indicated. So let me just indicate the T somewhere. Where are we? Okay, let's put a T here. Okay, so we needed to have T here. Alright, so we needed to have T. So let's put in T here. And where can I go? Here. Do like this. Do like this. Do like this. Do like this. So this is the T. Yeah. So they're telling us that DAT is actually 40 degrees, and the angle BDC, so we have B, then D, then C is 30 degrees, and AT, which is this one, AT is a tangent to the circle at A. So it is a tangent to the circle at A here. Alright, so now guys, let's see the question where they're saying calculate. We calculate A angle CB, angle CBD. So CBD, we find out this angle here. All right. Then also they are saying we find out also which angle BAC. So BAC, this angle here. Then also we find out angle A or B. So we have A or B. So this angle here. So guys, this is simple. What you need to know for you to be able to answer this question are actually angle properties or circle theorem. So you need to go there and study a bit on circle theorem, because that's what we are going to use in answering this one here. All right, so let's start with the CBD. So we want to know CBD, this angle here. So we need to know this angle here. So for us to be able to know this angle, we need first to know that this angle here, guys, this line here which passes through the center, because we have been told this center here. So if we have like a chord here which passes through the center, and then we have an angle in the half of the sector, because this one can be now a segment, an angle in a segment like this one here. When it goes like that, this angle here is actually 90 degrees. All right, so this angle is 90 degrees. So if this angle is 90 degrees, then we are going to say this whole angle is 90 degrees. Then this BCD, this one becomes a right angled triangle. So a right angled triangle equals to 90 degrees. So we can say now, for us to be able to find this angle here, what we can do is this. So we can say that let's say A, we are finding A. So we are going to say angle C B, then D is equal to, oh sorry, instead of it saying is equal to, so we are going to say plus this angle plus 90, this 90 here, plus this 30 here, must give us 180 degrees. Then what we are going to do is to again say, okay, angle C B D, then we add, first we'll say plus, then we add these angles, 90 plus 30, which is going to give us 120, all right, then which will give us 180, all right. Then now what we are going to do is to collect like terms. So this will jump this side, so that we'll have C B D is equal to 180 minus 120. So then we'll say equals, then we'll get our calculator, we'll say 180 minus 120 equals 60. So which means that this angle is 60. So this angle here is 60. All right, so let's find again B. B is asking us to find what? To find the angle B, angle BAC. So which one? BAC. So BAC is simple, guys. This one is the simplest. So let me just rub what is inside here again. So when you look at another property of circles, if you have this line chord, so angles subtended on the same chord, like we have this chord, there's an angle here from this chord which comes here. So this angle here, there's this angle here coming from this chord, it goes like that. Again from the same chord, there's this angle here which goes like that. All right, so angles subtended by the same chord are equal. So here you are not going to waste time. You are just going to say that angle BAC. So you say angle BAC is equal to 30 degrees. And the reason you give, the reason you say angles subtended by the same arc are equal. So you say angles, sorry, I don't have a writing pad, guys. Once I have it, things will be going fast. So angles subtended by the same arc or chord, I mean. So that one is a chord are equal. Okay, then it's moving, right? So let's continue pushing it back. So we have answered those. Let them remain those answers. Let's deal with this one first. We create again space here. Okay, what's going on? I want to push this one down. Okay, this one should do. We create another page, so this one should be in the next page. Okay, because we are also solving this one. Okay, good. So now we answered those others. We have left these answers here. You check them up for A and here for B, and then we come to C here. So let's answer, oh sorry, C. So for C, they want us to find which angle, A or B. So they want us to find the A or B. Okay, A or B, this angle here. So again, this angle is simple again. So for you to know this angle here, either you must know this angle here and know this angle here, then you subtract those angles from there, from 180, yeah, to know this one. Or you must know this angle here to know this one here. So I'll go with this one. I'll use two methods so that you are acquainted to both ways. So we want to find this angle here. But I'll go with this method, first finding this angle. When I find this angle, then I'll say 180 minus this angle, it will give me this, because angles on the straight line add up to 180. So now, can I know this angle? Yes, because we have been told that what have we been told first? Wait a minute. So again, when you have a tangent like this one, so this angle here, which is a 40, it's also equal to this angle here. So this angle also is 40. So this angle is also 40, guys, because according to the rule, which says, let me just maybe pull it out so that you prove where am I? Yeah, progress in mathematics. Good. So this is progress in mathematics, and this is called theorem 8. So according to this theorem 8, they have said if a chord to a circle is drawn from the point of contact at which the tangent touches the circle. So they are saying if a chord to a circle is drawn from the point of contact, so they are saying if a chord like this one is drawn to the point of contact at which the tangent to the circle touches. So this is the tangent to the circle. So a chord like this one is drawn, or there's also another chord, this one. They are drawn from this tangent. So these are chords. Now they are saying then the angle which the tangent makes with the chord, the angle which the tangent makes. So this is the tangent and this is the chord. So this angle here which the tangent makes with the chord is equal to any angle in the alternative segment. So this angle is equal to any angle in the alternative segment. So when you look at this one here is a small segment, then the alternative segment is this one here going here. So when you cut this whole part here is the segment here. So meaning it is this angle is equal to this angle. Again, if you come on this side again, you consider this angle here. This angle here between the tangent and this chord here, this angle is equal to this, though they haven't mentioned. This is the property here. So if you have this book, study it, you understand. But since we are solving, I just wanted you to get the point there. So now what we mean is that this angle here is the same as this one. All right. So if this angle is the same as this one, now we are going to use another angle property which I want to show you. So if this angle is equal to this, then this same angle is equal to this here. So this one also is 40. That's the beauty about it, studying properties. So this is 40. Why? Because this angle, when you look at this chord again, this chord here, so it subtends this angle. This angle is coming at this same chord here and here, and there's another angle. This angle again is coming from the same chord. So these angles are equal. So this and this are equal. Now, the beauty part about this again is this. So when you check again, there's this angle here, which comes here, and it comes here. So it comes to the center, comes back here. And the same one which comes from there, it goes there. So according to another theorem, it says that an angle subtended by the arc at the center or by a chord at the center is twice to the angle subtended by the arc at the circumference. So this angle it has subtended this chord at the center is twice this angle it has subtended at the circumference. So meaning this angle is 8. Since it is twice that angle is 80. So since that angle is 80, then this angle now here, it will be simple because 80 and this angle, they lie on the same line. So the straight line here, the angles on the straight line add up to 180. So now here, you are just going to say that the angle A or B is equal to 180. This one 180 doesn't come out clearly. My mouse is getting stuck. So this one is 180 minus 8, which will give us 100. So this one is 100. So let's move to this other question. We are done here. So this question also was written in 2019, July, August exams. For GCE, it was on question 16. They are saying in the diagram below, A, B, C, D, and E are points on the circumference. Again, the similar. A, B, C, D, E are points on the circumference of a circle. This is the circumference of a circle with a center O. This center O. Then they're saying DE, this line, DE is equal to AD. So these lines are equal. Again, they're saying angle ACB, angle A, then C, then B. That angle is 20 degrees. And angle AOE, which is AOE, is 80 degrees. Then they say find A angle ADE. Angle ADE. So simple. Then B angle DAE. So angle D, then A, then E. So they want us this to find this angle here, angle DAE, and also angle BAD. So BAD, that angle here. All right, so let's start with this first one, A. So let's push it a bit here. So we are going to say A. So this one is simple. So angle ADB. So they want us angle ADE. So ADE. So angle AD is equal to this one 80 degrees divided by 2. Now remember the reason we gave. So you say when you check this angle ADE, it is subtended by the same arc like angle AOE. So they are coming from the same arc, but this angle AOE, it is at the center, but this one it is at the circumference. So the angle subtended by the same arc at the circumference is at the center is twice that angle at the circumference. So you say, you give a reason. You say angle, or sorry, handwriting with this mouse is hard. So you say an angle subtended. Okay, here say subtended. The mouse, why is it holding it? It's sometimes not moving. It's not my doing. Trying to move it, it is getting stuck. So subtended. This is why I wanted a guy to do this, because I wish I can do it on a paper. Except my phone, again, it has less resolution. If it has high resolution of capturing what I saw on the paper, I could have used it. So angles subtended at the center, is twice. Okay, so you just say angle subtended at the center is twice the angle subtended at the circumference at the same arc. Yeah, something like that. That's what the reason you are supposed to give, rather than me writing here. You have seen I'm struggling to do that. So then, which means that when you divide this one, you find that you get your angle as 40 degrees. Then you go to B, D, A, E. So which one? D, A, E. So they want us to find this angle here. Now, what you should know is this, that these sides, they've told you that they're equal. This side and this side, they're equal. So if these sides, they're equal, it means once you know this angle here, which is, we are saying it's 40, this angle then becomes what we call an isosceles triangle, because an isosceles triangle is a triangle which contains two sides that are equal. So if the two sides are equal, meaning these two angles also are equal, this angle here and this angle, they are equal. So if they are equal, then for us to find this one, we can just say that to find this any of these two angles, we like here, let's say D, angle D A E is going to be equal to 180 degrees minus 40 degrees, then everything divided by 2. Then from there now you say equals, what you are now going to do is to say 180. Now you get your calculator, you say 180, which will be 140, right? 180 minus 40, which will be 140. So you get your 140, then 140 divided by 2, okay, which is 70. So this angle is going to be 70 as your answer, because this is 70 and this is 70. We got 140 for two of them, then we divide by 2 because there are 2 to get 70. Then if we go to BAD, now we want to find angle BAD. Okay, so let me rub again what is already here. So angle BAD. So for us to be able to find this angle, which is BAD, the whole of this angle here, we must first know what this angle is, what that angle is, for us to know. So however, it will be simple for us to know some of these angles, because when you check, like here, we have this line going like this. Here, this is the same arc here. This arc here, we have this line going like this, making this angle 20, and this same line going like this. So meaning this angle and this angle, they are equal. So now we have known now that that this angle also is 20. Now if this angle is 20, now we need to know this other angle here. So this other angle here can be known if we know which other angle can we know here. Let me just check. Okay. Because we have known everything here. So this angle, we have known it. And this angle we need to know. Yeah, so now what we need now to know, yeah, I've seen it now. So always there's a clue. So we have already known this angle here. This angle and this angle, they are equal. We found it to be 70. So this angle and this angle is 70. Now there's another property here. Let me just get this book of Excel so that I take you back to angle properties, because these angle properties are the ones that helps us to answer these questions. When you study them, they help us to answer. Excuse. think this is the one I'm here now. Theorem number 4, which says that the opposite angles of a cyclic quadrilateral. So the opposite angle of a cyclic. So this one is a cyclic quadrilateral which has 4 angles: 1, 2, 3, 4. It is called the cyclic quadrilateral. And then the opposite angle, like y and x, these are opposite. So these are known to be supplementary, meaning when you add them, they should give you 180. So this angle and this angle should give you 180. So when you come to this equation which we are solving, this question we are solving here, when you look at this angle E and this angle, they are opposite, and this angle. So also here, when you get this angle which goes like this, you get what we call the cyclic quadrilateral, something like that. Yeah. So you get this one, meaning this angle here and this angle here are supplementary. If you add them, they give you 180. So meaning that we are going to say for C, where we have angle BAD, we are going to say it is going to be angle DAB plus. Now this angle here, this angle, we already found that even in this one, these two are 70 each, plus 70 must give you 180 degrees. So now this now will cross to the other side, where you have now BAD is going to be 180 degrees minus 70 degrees. So again, you get your calculator, you say 180 minus 70, which will give you 110, which will give you 110. So it means that this angle here now, this one is 110. You are done. So today we are done with this. I hope if you want Excel so that you can study on these, then you can request for it so that I can assist you. You study those properties. They are very important that you know them because they'll help you. Otherwise, for now, this is where we can end until tomorrow again. Bye and see you then.